Bismillahirrahmanirrahim. Assalamu alaikum students. This is the second video on the testing hypothesis. In this video, I am giving some examples regarding to perform the testing hypothesis. Example number one: you are the manager of a fast food restaurant. The business problem is to determine whether the population mean waiting time to place an order has changed in the past month from its previous population mean value 4.5 minutes. Students, in these lines you have given that the previous value of the population mean was 4.5 and now it has changed. It has changed means not equal to 4.5. These lines not saying that the mean waiting time has decreased or increased. It just says that it is changed. From the past experience, you can assume that the population is normally distributed. This is very important. Student, the data should be the normally distributed. With the population standard deviation is 1.5, 1.2 minutes. You have given the standard deviation related to population. You are select 25 orders during 1 hour period. This is the sample size consisting consist of 25 observations. The sample mean is y 5.1. This is uh, calculated from the sample of 25 observation. It is to determine whether there is evidence at 0.05 significance level. The significance level is 0.05, which divides the two region, acceptance and rejection. I'm reading again. The sample mean is 5.1. It is to determine whether there is evidence at 0.05 level of significance that the population mean waiting time to place an order has changed in the past month from its previous population mean value 4.5. The previous population mean was 4.5. This means H naught is 4.5. And now the manager is claiming that the time has changed to 4.5. This means is not equal to 4.5. This means the test is either for the increase or for the decrease. This means the two-tail test. This problem is based on two-tail test because the null hypothesis, the alternate hypothesis is not equal to 4.5, is not equal to the previous population mean. The sample observation students are 25. The mean from the sample is 5.1. The standard deviation is given 1.2. Statistical level is 0.05. The rejection region from the normal distribution table has calculated is plus minus 1.96. Because it is two tail, therefore I have used plus minus sign to denote the negative and positive rejection regions. Null hypothesis we have discussed, alternate hypothesis we have also discussed. Now students, the test static. The test static we use in this problem x bar minus mu upon sigma because standard deviation is given. Now student, substituting the values, the null hypothesis is mu always. We will substitute the value of the null hypothesis here, and the sample mean is 5.1. Therefore, we substituted for 5.1. Standard deviation is 1.2, and just we have calculated from the calculator, and now we have obtained positive 2.5. Now, student, the critical region we can find from the table as I have here mentioned from the screenshot. The step number one, this the objective of the showing this table is to know how to calculate the critical region from the normal distribution table. Is this to find the critical value? There are three main steps. I have divided into three main steps. Number one, divide the significance level by 2 because the test we have given two tail test. So 0.05 divided by 2 is 0.025. Step number 2, subtract the answer of step number 1 from 1. This means we have to subtract 0.025 from the first step from 1. Okay, 1 minus 0.025 will give us 0.975. Step number 3, search the result of step number 2, which is 0.975 in Z distribution table as directed by the arrows. Students, I have searched in this table, I have found 0.0975, and the header of this is 0.06, and the row connected to this value 0.975 is 1.9. Now just we have to add 1.9 and 0.06, so we will get 1.96. 1.96 is 1.96 is the critical value. Now making the normal distribution, the rejection and acceptance region. Here student, 1.96 positive show the left side or right side rejection region, and minus 1.96 show the left side rejection region. 0.25 is the probability in the rejection region. Here is also 0.05 divided into two parts, 0.25 on the right side and 0.25 on the left side. Now student, what is the test static value? We have to see in which region it falls. It's going to fall. Now the test static value was 2.5, positive 2.5 here. Just we have calculated. Now going to see in which region it is falling. Students see 2.5 clearly falling in the rejection region. In the rejection region 2.5, because 2.5 is greater than 1.96 and it fall in the rejection region. So what is the conclusion? You reject the null hypothesis because test static fall in rejection region. You conclude that there is evidence that the population mean waiting time to place an order has changed from its previous population mean value of 4.5 minutes. The mean waiting time for customer is longer now than it was last month. Why it is became longer? Because see from the um, sample mean. Sample mean is 5.1, and what was the previous null hypothesis value? Value was 4.5. So 5.1. This means it is increased. So therefore, I use the word it is now increased. Now, student, I am going to another method from which through which I will calculate the same. Um, I will apply the testing hypothesis test by using p-value method. Example number one, by using p-value method. P-value method is a second approach used in testing hypothesis. Following conditions holds for the acceptance of rejection of the null hypothesis when p-value method is used. Number one, p-value is less than. If I calculated the p-value and which is less than the significance level, then reject the null hypothesis. The approach, the condition two, p-values, if p-value is greater than the significance level, then accept the null hypothesis. Okay, now students, I'm going to find uh, the p-value from the calculator because it is standard deviation we have given, and therefore we use the normal distribution curve, and we know um, it was the two-tailed test, and we can find the rejection region, sorry, the p-value or the probability from any of the region, from the left side or from the right side, sorry, from the right side or from the left side. If we find from the right side, I will apply the in calculator. I will calculate from the calculator from the right side option. Now I'm going to find from the calculator. Okay, now students, I am sharing the screen of the calculator. Here we are. Um, sure, because I am going to find the distribution, normal distribution value at the 2.5 and from the right side. Now changing the calculator from the stat mode or normal mode to stat mode, and it is on the three, option number three. Student see from the screen of the calculator. I'm press 3 and now pressing equal AC, and now shift 1. The calculator changed to distribution on the 5 option. Now I have pressing the button 5. Now I have P, Q and R. The R value is on the 3 option, so I am pressing 3. Now student, I am giving the value of 2.5 because I need to find the probability greater than 2.5. Here is equals to, it is 0.00620997. Student, if someone want to find from the left side region, so he can find. I'm telling you how to find this one. Press shift and 1, and distribution is on 5. Press 5, then press 1, because the value is on the left side, and because we know that 2.5 is in negative value from the left side. So this, that is why I have written here in the calculator minus 2.5 is equal to, this will lead the same value 0.006297, which is from the left side. So it is up to you students, if two tail test you perform, then it's up to you, from the left region or right region you can find the same value. You will obtain the same value. You can find from you have choices. Now student, I have found, this is I have done for you from the left side option. And now students, the p value I have found is 0.006207. Now I am finding, uh, dividing the level, the statistical level with 2, because it is two tail test. Now I'm again, I have in this box, I have given you the p value method again. Here you can uh, you can re study it. Objection point number 1 was, if p value is lesser than significance level divided by 2, then reject the null hypothesis. Okay student, I have obtained. Now what we have obtained in this para, I have explained. We get we get from the p-value method that p-value is less than significance level. This means 0.006297 is lesser than 0.025. Therefore, we reject the null hypothesis. We conclude that the mean waiting time for customers is longer now than it was last month. Now, student, going for the example number 2. Example number 2 is, a company that manufactures chocolate bars is particularly concerned that the mean weight of a chocolate bar is not greater than 6.03 ounces. Uh, a sample of 50 chocolate bar is selected. The sample mean is 6.034 ounces, and the sample standard deviation is 0.02 ounces. Use the 0.01 statistical level significance level. Is there evidence that the population mean weight of the chocolate bars is greater than 6.03 ounces? Student, we have to, they are saying that the previous value was 6.03, and now the value is changed to greater than 6.03. So the claim of the manager is, the mean waiting time, sorry, the weight of the chocolate bars is increases or greater than 6.03. Now students, n was 50 and x bar 6.034 ounces. Standard deviation of the population was not given. So 0.02 was the sample standard deviation, or is the sample standard deviation. Significance level we have given 0.01, and Z alpha, not alpha by 2, because it is one tail test. Because from the alternate hypothesis that it is given that the chocolate bars is greater than 6.03 ounces. It means the population variance or population mean is changed. Therefore, change from what, greater than 6.03. So student, this is one tail test on the basis of the alternate hypothesis, and the null hypothesis was 6 point lesser than and equal to 6.03, because these two are opposite in sign, and the null hypothesis is always equal with equal sign. Okay, students, as population standard deviation is unknown, but sample size is greater than 30, therefore we use normal distribution. This is the test static we use. We use S, the standard deviation of the sample, instead of the sigma. Okay, now student, substituting the value in the test static, we will get Z is equals to 1.414. Okay, finding the critical value from the table. Student, it is a one tail test. Step number 1, subtract the given value from 1, because we didn't divide the significance level because it is one tail test. So therefore, it started from the step number 2, and from our problem, it is step number 1. Okay, so subtract the given value from 1. 1 minus 0.01, we obtain 0.99. Step number 2, we will search in the table the value of 0.99. Okay, student, from the table, I have obtained 0.99, and the header of this value is 0.03, and the row associated with 2.3. So we will add 2.3 and 0.03. So we will get 2.33. This is the critical value from which the rejection and acceptance region are divided. Okay, students, this is the value, and this is the normal distribution curve. And from the right side, you have seen 2.33, which was the critical value, and this is the rejection region, and this is the acceptance region. Okay, student, now we will see what was the test static value. Test static value was 1.414, and we have to see where in the rejection region or the acceptance region this value lie. Uh, the Z value, the Z statistics value lies in the acceptance region. Therefore, we accept the null hypothesis and conclude that the mean weight of the chocolate bar is not greater than 6.03 ounces. Because student 1.41 lies here, and the rejection region starts from 2.33. So 1.414 is here, therefore in the rejection region, and from this um, we conclude that the mean weight of the chocolate bar is not greater than 6.03, and we accept the null hypothesis. We accepted the null hypothesis. Now, student, from the p-value method, this is the rule I have written again for you. Now, student, I am going to see, because it was the rejection region made in the right side. Therefore, I will see the probability greater than 1.414. Okay, I will use again the right side region because the rejection region is in right side form, and from the calculator I can calculate for you students. Now I am showing the screen of the calculator. Student, here we are. This was the previous value. Now shift N1, 5 distribution, and R at the 3. Now I will substitute the value 1.414, and I will obtain the probability greater than 1.414 is 0.786. 0.786, student. Now I'm going to again to the lecture screen. Here, student, the p-value is 0.078. The statistical level was 0.05. Now the result we get from the p-value method. The p-value is greater than significance level because 0.07 is greater than 0.05. It is one tail test, therefore we didn't divide by 2 the statistical level. The p-value is greater than significance level, therefore we accept the null hypothesis. We conclude that the mean weight of the chocolate bar is not greater than 6.03. Okay, student, now I'm going for the problem number 3. The problem number 3, example number 3. Example: a random sample of 64 observations has mean 36 and a standard deviation is 5. Test the null hypothesis. We have given null hypothesis h naught mu is equals to 40 against the alternate hypothesis, which is h1 is lesser than 40 at 0.05 significance level. Student, one point here I want to explain. I have told you before that this is lesser than, and it should be h naught is greater than and equal to. Okay, you can, because equal to is also value of h naught, therefore we can also write equal to here. And otherwise, if someone want to write greater than equal to 40, then he can write. Both the ways are correct. Now, student, data n was 64, s was 5, and we have given this null hypothesis and alternate hypothesis. Significance level is 0.05, and I have calculated from the normal distribution table. The critical value is 2.33. minus 2.33. Why minus? Minus because it is on the left side from the alternate hypothesis. Therefore, it is one tail test and left-sided test. Okay, student. Now, I didn't calculate from the table. No, just going for the calculating the test static value. Okay, student. Then x bar was 36, and the sorry, null hypothesis was 40, standard deviation was 5, and n is 64 because the n is greater than 30. Therefore, we have used this table, and the test static, test static is minus 6.4, and we have obtained the critical value was 2.33. Now, minus 6.4 is lies in this rejection region because it is greater than minus or lesser than minus 2.33. So therefore, it is here. So the test static lies in the rejection region. The value of the Z testing lies in rejection region. Therefore, we reject the null hypothesis and conclude that the mean is less than 40. And the previous value of the population was rejected, the null hypothesis, and concluded that the mean is less than 40. Okay, student, from the p-value method, this is the table that again I have written for you because it will refresh you. This is the value, student, for two tail test and one tail test. Conditions for the, now we know the test was the rejection region was in the left side. Therefore, p I use p minus negative 6.4. Now, student, from the table I have calculated this one, or from the calculator I have calculated this value, and this value is 0.000000 till 11 times zeros after the decimal point. It is very minimum value of this value. So the answer is, we get from the p-value method that the p-value is lesser than significance level. This is the lesser than 0.05. The p-value is less than significant level. Therefore, we reject the null hypothesis and concluded that the mean is less than 40. Okay, from the two methods, you have found how to calculate the test hypothesis, or hypothesis testing. Now, student, example number 4. Example number 4, a random sample of size 20 from the normal distribution uh, has mean is 16.4 and standard deviation is 2.255. Does this suggest at 0.05 level of significance that the population mean is greater than 15? This is the student we have given is greater than, this means we have given the alternate hypothesis is greater than 15. Okay, now obtaining the data from the problem, n is 20, x bar is 16.4, 2.2 significance level. Because the student n is lesser than 30 and population standard deviation is also not given, therefore the t scores will use at 0.05 significance level. T distribution table, I have calculated 1.729 T alpha. Why not alpha divided by 2? Because it is one tail test and from the right side test also. Okay, this was the data obtained from the problem. Now, students, I am going to calculate the critical value from the T distribution table. Student, it was given the level of significance was 0.05, 0.05, yes, 0.05. From 0.05, and the degree of freedom. Degree of freedom is what? Degree of freedom is a parameter of the T distribution. Therefore, degree of freedom is n minus 1. Degree of freedom is n minus 1. N is the sample observations was 20. 20 minus 1 is 19. And statistical level was 0.05. So 0.05, from 0.05 and from the degree of freedom column 19, both the value converges at 1.729. Therefore, the critical value or T critical value is 1.729. Okay, student, now I'm going to calculate the test static value, this time not the Z distribution table, but from the T distribution table. Substituting the values in this test static, I will obtain, or we will obtain 2.776. From the figure, it is confirmed that the test that this is the left-sided test, student, uh, because right sided test, and the value rejection region start from the 1.729. Okay, student, what was the test static value? Our test static value was 2.776, and 2.776 lies in the rejection region. Therefore, we reject the null hypothesis and conclude that the mean is greater than 15. Now, student, from the p-value method. Example number 4 from the p-value method. Significance level was 0.05, degree of freedom was 19. The test static value is 2.77. Student, we have to search 2.77 and degree of freedom 19 in the distribution table to get the p-value table. P-value, sorry. Search test static value 2.77 in the row of degree of freedom 19 and follow the steps given in the table, in the T table. Degree of freedom is 19 and we have to find 2.776. Now, student, from this table, this is the T table, T distribution table. This table has given both the values at two tail and one tail. This is for the one tail and this is for the two tail row. Student, from the degree of freedom is 19. From the row of degree of freedom 19, I will find in the row, in this row, 2.77, 2.776. Student, you can see 2.776 is greater than or between these two values in this region. 2.55. I am zooming zoom in to clear the view. We have to find the 2.776 in the 19 of degree of freedom. So 19 of degree of freedom, this row, and 2.77 lies in this in this interval from greater than 2.539 and less than 2.8. From the header of these two columns is 0.01 and 0.005. The p-value lies in this range. Now, student, I'm writing this range in the next page. See, student, here. From the T table, we have found the p-value lies in the range given below. The range is this 0.0, 0.005 to 0.001. Okay, student, compare p-value with the significance level. We get from the table p-value is less than the significance level. Therefore, we reject the null hypothesis. P-value was 0.05 and p-value is lesser than student p-value 0.05 and the starting from 0.005 range 0.01. So 0.05 is in between, is lesser than the p-value. Sorry. Um, I did mistake. I think we get from the table that p-value is less than. The p-value is less than because 0.05 is greater than this range. 0.05 is greater than this range. Therefore, p-value is lesser than this range. Therefore, student, I'm reading again. We get from the table p-value is less than the significance level. Therefore, we reject the null hypothesis. This is from the solution from the p-value method, student. Now it's up to is enough for the today's video, student. Now I'm inshallah ta'ala going coming for the coming. I will come from the next video. Till then, assalamu alaikum, students. Allah Hafiz.